Hello guys, in this video I would like to explain the construction of frequency table using group data. Before this we have done frequency table, we have constructed frequency table for ungrouped data. And if you are not aware that how we can construct a frequency distribution or frequency table for ungrouped data, the link to that video is given in the description of this video. So you can just click and watch that video that how you can do that. So this now we need to talk about group data. What is mean by group data? When there is a variation in the data or the data is continuous, in that case you can create some groups interval, and there are some rules for the construction of groups or class intervals. We need to follow those rules. There are 4 or 5 rules, and we will talk about those rules because this video is about the general procedure of constructing frequency table using group data. So let's move to the material and that how we can construct frequency table using group data. And uh, we can see here the general rules that we will need to apply when we have continuous data or large data with the variation. So this is the procedure. That the first step in this construction of frequency table for group data. Organize the data, collect the new or the raw data, ensuring it is well organized in a list of columns. Grouping is needed when dealing with the continuous data or large data sets. So this is obvious that in which case you can create group in a data that can be continuous data or large data sets. So this is obvious now. The second step is determine the range. So the range is maximum value minus minimum value. So you need to identify the maximum value in the data and minimum value in the data. Then you can calculate the range. The third step is decide the number of classes. So this is crucial step. The number of classes or intervals can be determined by a simple rule such as Asterisk rule or the square root rule, or the third rule is this one C. So we can use any of these rules, but mostly I prefer this one, this rule C, 2 power k greater than n. Let's talk about each of them. Sturgis rule, k is equal to 1 plus 3.322 log n. So now we can talk about what is k. K is the number of classes or the groups, and log is log, and n is the total number of data. So you need to put you can calculate the class intervals or the groups k uh, by using this expression 1 plus 3.322 log n. N is the total number of observation. Just put n here and then simplify this side, the right side, and you will get k. You will get a value for k. So that is the number of classes for you. The square root rule is k is equal to square root n. So this is very simple rule. Just take the square root of total number of observation, and that will give you a number for k. So that is the number of classes. And the third rule is 2 power k greater than n. So k is the number of class intervals. So this means that you just need to put k for 2 power k. K can be 1, 2, 3, 4, 5, 6, and this will give you a number. Suppose 2 power 2 is 4 and 2 power 5, that means 32, and k is 5. So there you mean that you have 5 class interval if this equation is satisfied. If suppose n is equal to 30 and you calculating 2 power 4, so that makes 16, that is not satisfy this equation. So this is not the appropriate number of class interval. So if you put it k equal to 5, then this makes 32, which is greater than 30 because we consider n 30. So in that case, this equation is satisfied, and k equal to 5 is the number of interval in this case. Okay, we have now example. Okay, yeah, we have okay, no example. So this is general procedure, and we were talking about this. This is example of that when you have n is equal to 100 and the data points. So k is equal to 100, and that will give you 10. Square root 100 is equal to 10, so 10 number of intervals. And if, by the way, if you are using the two rule, the Sturgis rule or the rule C, that will give you a different number of intervals, perhaps less than this. So this does not make difference, but you need to be careful about when you are when you are putting data in these classes. And the fourth step is determine the class width. That's also important, very important. Class width can be determined by class width is greater than equal to range divided by number of classes. So you have range, and step 2 you have determine the range here, and step 2, and step 3 you determine the value of k. So number of classes, so you just put here range divided by number of classes, and this should be greater than equal to this one. You may round up the classes width up to an easy to interpret value for simplicity. So you can, of course, round up this value. And the fifth step and the last step is set class intervals. Create the class intervals based on the chosen class width. Each class should include a lower and an upper boundary. Make sure the intervals cover all the data points and they do not overlap. So this is very important. They should not overlap. I mean that you can include exclusion and inclusion rules. So we will do that in example. So it should be careful that how we can distribute data among different class intervals. So this is all about how we can construct frequency distribution or frequency table for group data. And this is the general procedure, the 5 steps to follow to construct a frequency table or frequency distribution for group data. And remember that we can use this procedure, I mean that group data procedure, for continuous data or large data sets. So this is enough for today, and see you in the next video. Ciao.